Okay, good morning. Let's start working through this workbook 4. I'll try to take on each of the sections. The first section is being discrete probability distribution basics. It's got 4 problems, so I'll do a pause at the end of each problem here. So here's problem 1 up on your screen. It says you flip 4 coins, let x be the random variable, and let it be the total number of heads on all 4 coins. So first it says list the sample space for the experiment, and you have to go back a chapter and remember that these tree diagrams are probably your best bet for creating the sample space. And I'm not going to go through it in detail, but there is just right here on your screen. And all you have to do now, that's the sample space. The second question is, what are the possible values of x? Well, you sort of knew that before you started because you're flipping 4 coins, so you can get all tails, no heads, 0, 1 head, 2 heads, 3 heads, 4 heads. So x goes 0, 1, 2, 3, 4. X then is all the values of this, all the possible values of this random variable. And the next question is it continuous or discrete? It's very clearly discrete. It is just the number 0, 1, 2, 3, 4. And then the last question says, can you construct a probability distribution for this experiment? So now you have to go back to this tree, and you have to note that there are 16 values, 2 to the 4th values or possible outcomes, 2 to the 4th, 16. So let's count up all of those values associated with x equals 0. And there's just one down at the bottom, right? There's tails, 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 tails. There's no heads in that, only one. And if you do the same thing and look on the other side for how many, what I'm really counting is how many different ways does the random variable value 0, or now I'm going to go to 4, how many different ways does it come up? And both of those just come up one way, right? 0 comes up in the tail, 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 tail. Heads comes, 4 heads comes up just once. Heads, 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 heads. And so that's what I'm going to do to finish filling this tail out. I'm going to count the number of different ways that one head comes up. It comes up head, tail, 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 head, tail, 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 head, tail, and it comes up tail, 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 head. Those are the 4 ways that that one head comes up. And I'm going to write against the probabilities then 1/16 for 0 and 4, 4/16 for 1, and as it's going to turn out, if you count up the number of ways to get 3, then 3 heads, then you're going to find that's 4/16 as well too. And the final case has to be 6/16 because all of those probabilities have to add up to 1. And if you those aren't easy to count, but go ahead and count go back to the tree diagram and count how many different ways 3 heads comes up. Or sorry, 2 heads comes up, and you're going to find that there are 6. Okay, so there is the probability distribution for this particular experiment. Just for kicks, since I've got some white space, let's do this. Let's calculate the average. Okay, remember we're going to be using this quite a lot. Sort of like you to know what's behind the average. Here's the formula. All you do is in each one of these columns in this probability distribution, you multiply the x by the corresponding piece of x, x by the corresponding piece of x, x by a piece of x, and add those all up. That's the average. If I wanted to torture you, I'd say let's go ahead and calculate the standard deviation. We'll do that actually in a second. In that case, once you've calculated the mean, as I have right there, you subtract x and the mean, square that value, multiply that by the corresponding probability, do that for all the values, add those all up. That's the variance, take the square root of it, that's the standard deviation. Okay, I think we beat the heck out of problem 1 there. Let's pause and let's go on to problem 2. Okay. Okay, here comes problem 2 in the discrete probability distribution basics section, coming at you like a Gatling gun. It says, determine if the following are probability distributions, if no, state why. I got to tell you, when you're looking, when you're assessing things as to whether or not they're probability distributions, you're really looking just at the probabilities, because they have to satisfy the criteria that they're all between 0 and 1 inclusive, meaning they could be 0 and they could be 1. Okay, if they're outside that range in some way, if they're negative, if they're greater than 1, then this can't be a probability distribution. So let me go look across at A, 3, 6, 9, 12, 15. Hey, if there's a finite number of x values, then it's by definition discrete, okay? And those can take on any values. But below, probabilities have to do 2 things. They have to be between 0 and 1. All of those are. And they have to add up to 1, okay? So 4 ninths and 2 ninths is 6 ninths. 1 ninth is 7 ninths, another 1 ninth is 8 ninths, one other, adding the last 1 ninth is 9 ninths or 1. That's a probability distribution. If you look at B, same thing, everybody, all the probabilities are between 0 and 1. If I add them up, I get 3, 4, 5, 6, 7, 8, 9, 10 tenths. That one is a probability distribution. But if I go look down at C, C is challenged, because right off the bat, the first probability underneath the first x value 20 is 1.1. Thank you for playing the game. That is a probability that is outside its range. At 1.1, you're not even going to, everything else is positive, you're not even going to add up to 1, but you've got a value that is not in the range 0 to 1. C is not a probability distribution. Okay, on to problem 3. All right, I'm looking at problem 3 here in discrete probability distribution basics now. It says a die is loaded in such a way, 6-sided die, that you get 1, 2, 3, 4, 5, 6, but you do so with uneven probabilities, which means, as it says, that die is loaded. It's not a fair die. And those probabilities are, and it says respectively, so that means that the 1/2 goes with the 1, the 1/6 goes with the 2, the 1/12 go with the 3, 4, 5, 6. So it says construct a probability distribution. All you have to do is write 1, 2, 3, 4, 5, 6 across the top and the corresponding probabilities, 1/2, 1/6, 1/12, 1/12, 1/12, 1/12 across the bottom. And as long as those probabilities, A, are between 0 and 1, B, add up to 1, you've got yourself a probability distribution, and we move on. So if I add up all of those fractions, 1/2 is 6/12, 1/6 is 2/12, so I've got 6 8/12, and I've got 1, 2, 3, 4, another 4/12, that adds up to 12/12, and that is problem 3. Okay, off to the last problem. Okay, final problem. Maybe by this time you've got the idea that what I'm trying to get across in these 4 problems is a probability distribution has values of x, corresponding values of p. There's some constraints on p. They got to be between 0 and 1, and they've got to add up to 1. So here in problem 4, I've got a set of probabilities, but I'm missing one. And it wants me to fill in. The first question is, says find the probability that goes in the missing box. Find p of x equals 2. So all I've got to do is add up all of these guys. Right now I'm adding 0.41 to 0.38 to 0.08. I would have done this in my head, but it's just too early. 0.03 plus, I get 0.9, which means x is equal to 2 has got to be equal to 0.1 so that they all add up to 1. Okay, so now the question it asks, and this is something you're going to find yourself doing a lot, so you're kind of building a basic skill here. It says find the probability that p of p of x less than 2. So let's think about this for a second. All of these probabilities are mutually exclusive, right? When you run whatever experiment you're running here in problem 4, you're going to get 0, 1, 2, 3, 4, or 4 as a result. You're not going to get combinations of those on a single result. Yeah, from trial to trial, you'll get different values, but on a single trial, you're just going to get one of those. Makes it mutually exclusive. That means if you want to find the probability of x less than 2, that's equivalent to finding the probability that, that x is 0 or 1. And remember, the addition rule says mutually exclusive events. You just add up the individual probabilities. So in this case, the probability that x is less than 2 is 0.41 times 0.38. I'm pretty sure that's 0.79. Okay, likewise, the problem C says find x less than or equal to 2. So now to that 0.79, I have to add our 0.1 we found earlier to get 0.89. That is, I'm finding the probability of x being 0 or 1 or 2. Piece of 0 plus piece of 1 plus piece of 2. Okay, and finally find piece of find p of x, or if x equals 3 or x equals 4. I just go look in the boxes. If p of x equals 3 or x equals 4 is p of 3 plus p of 4, that's 0.08 plus 0.03, that's 0.11. Okay, pretty simple stuff. On to the next section. Thanks.